On? Something I sent to you yesterday. Yeah, after the but wait, I think there's one part I need to qualify. There's one part I need to put. I want that document. I want that document. The one you're editing.
Hi everyone. So we're just going to wait a few more minutes before we start. Just give it maybe some minutes. So we will start at 17:35. That's like 4 minutes from now. Thank you.
So the totals in terms of what the data is seeing forward and back is what is here. And this is what now gives us the computation bandwidth that is sitting on the first part of that table.
So if there's no selfie download.
All right. Hi again. I think it's 17:36. It's a minute past when we said would start, and I see there's a few other colleagues that have joined us. So it's been a while. I think we missed about a week because of holidays or something, but that's okay. So we continue our discussion of I believe it's lecture series number 3. It is, and we had gotten to a stage, I believe, when we had just going to quickly. We're getting to a stage where we had, bear with me, by the way, I'm a bit behind here. I'm not really sure at what point we had gotten, but so what I'm going to do is I'm just going to see if I can in this slide. I know we had gotten to a stage where we were meant to start looking at examples of projects. I just can't have to re-download this, I guess. Oh, I think I can find this here. Just going to have to ask for confirmation. I think we had gotten to a stage where we had wrapped up our discussion of the CRISP DM model phases, right? The discussion, and we're supposed to really start looking at these case studies. Or did we start looking at the case studies, or we were about to start? Is it? Could somebody remind us? I mean, I could check the videos, I guess, but I thought maybe
about to.
We were about to start. Yeah, I remember. And I think there's actually this video recording that I have located somewhere. So what I'm going to do is I'm just going to. There we go. So we're about to start. Okay. All right. I'm not sure if there are any thoughts so far. We've had quite a bit of time, right? Maybe trying to digest the things that, and I hope this thing is recording. Trying to digest the things that we have looked at so far. As you're trying to think about potential questions, I just wanted to just a few announcements. There's 2 announcements really. So the first one is there's an assignment that has been made available. So it's open today, and it's due Monday next week. Details in the email. So I've attached the excuse me. I've attached the assignment itself. So you will notice that the assignment requires that you go through an easy read, I would like to think. So there's this paper called Summarizing ETDs with Deep Learning. There are some people I'm familiar with from Virginia Tech University that are working on some really interesting things by way of mining text data. So they're mining information from ETDs. They have massive funding to do that. And I was privileged enough to have attended the same event where they presented this paper. So I thought it would make for an interesting read as a very first paper reading assignment. The link is in the assignment itself. There's a direct link to the paper. It's published in an open access journal. So the proceedings for this conference were published in a journal, and that journal is open access. So you shouldn't have trouble accessing the PDF document. Instructions have been provided in the assignment in regards to what you're supposed to do, but I think we've already had a discussion centered around this also. Just make sure that you don't go beyond the limit, right? This is not supposed to be an essay. So just stick to maybe 1 page at most. Half a page is good enough, but 1 page at most. And the idea here is you want to focus on the more relevant aspects of the paper. more specifically, you probably want to revise the Kishav approach that we discussed, or whatever technique you found useful in trying to understand peer-reviewed articles or academic literature, if you will. So that's that. You notice from the assignment as well is I've again shared a direct link to a sample graded paper reading assignment. I think we had a discussion about this. So in that link, you will find this document here. I'm just going to quickly go to the document so that people are aware, those that are not aware. And I'm not sure if this is, there we go. So the direct link takes you to this document here that kind of like showcases how an example paper was graded, right? So with a breakdown of each of the different components associated with the rubric itself. So it should give you a guide on what is expected of you in the assignment. Now, the idea is this assignment is supposed to be made available via the Astria site, but I'm still having challenges with the Astria site. I'm hoping that the Astria site the issue would have been resolved by the time you're submitting your assignments. I'll follow this up again with the postgraduate coordinator, Dr. J. Piri. But there you go. So it's a fairly simple read, to be honest. Unless if there are any questions. The other thing I wanted to talk about is there's an event I was attending between the 21st and the 23rd of last month. Now this event, CSCDU, this is not supposed to be 2023 actually. I got a wrong snapshot. They've already started advertising for CSEDU 2023, which is next year. So if you're interested in submitting work there you go. So the interesting thing about this event, this conference, is that of course it's multidisciplinary, so you have people from all sorts of background. Although what I've noticed is that it's mostly frequented by people with a technical background, if you will. So you have people presenting work on novel software applications that I guess are aimed at making teaching and learning more effective. And increasingly over the years, we've seen a rise in the number of papers associated with so-called educational data mining, right, or learning analytics as it is called. So in fact, there were separate sessions dedicated to learning analytics and data educational data mining, EDM as it is called. And the reason I'm talking about this is if you're one of those people who perhaps has a knack for the education sector, you want to visit that site, and it's not IST, by the way, it's called CSEDU. Should change this. You go to the site, or you can just Google up CSEDU 2022 and just go to the link where the proceedings are, and you should be able to find them categorized based on the different thematic areas associated with the papers that were submitted or presented at the conference itself. Some really exciting stuff, right? Both learning analytics and educational data mining, both technical oriented papers and not so technical oriented papers. But I thought I would mention that anyways. Yeah, unless if there are any questions, maybe we can proceed with our discussion of lecture series. Now we can proceed and wrap up lecture series number 3, or module number 3, if you will. Any thoughts or questions about this, or anything else so far? Maybe the assignment. One more thing. We've had a bit of the person who had confirmed to give a talk today, unfortunately, are not available. So we're trying to see if we can have the second speaker, so Dr. Zulu, to come and give a talk. But we're still waiting for confirmation as to whether he's going to be available next Monday. So more information will be sent through about the scheduled talks, or the scheduled talk, the very first talk in the seminar series that we're going to have as part of this course. But anyway, so we really the most recent lecture was really more focused on trying to wrap up a discussion of the CRISP DM phases. So these 6 phases associated with this this approach to data mining, right? Systematic approach to data mining. Granted, we noticed that this is in fact not the only methodology or model, if you will, that you can take advantage of, right? So there's a number of them available. You can take advantage of the more common or more popular SEMA, for instance, or if you want, you can experiment with more modern approaches or techniques such as the CRISP ML model, for instance. Key to our discussion really was a focus on the series of activities that you undertake in each of these different phases, and why you undertake them. And I think what is interesting for this particular methodology or model is that there's certain phases that allow you to look back to the previous phases, but then there are others that would not really make it possible for you to go back, right? So the arrows here will help you determine which sort of phases will enable you to look back to the previous phase or something. So there's I think, is it 2 or 3 case studies that I thought we could walk through to help us reinforce the things that we talked about in regards to the 6 phases. So we're going to start with the first use case, which was a project, and I guess we could say it's a project because we've got into a stage where we're trying to see if we can actually deploy production quality, or we can link these models to production quality software tools. But in any case, so this project really it's associated with the automatic classification of so-called electronic theses and dissertations. So the motivation or the background to this project is that historically, the ingestion process, or the process of depositing electronic theses and dissertations into the institutional repository at the University of Zambia is problematic. It's marred by so many challenges. For one, there is no self-archiving, right, in place. So what do we mean? Well, in an ideal case, if you look at institutional repository used by the University of Zambia, it has a provision that would make it possible for user accounts to be created for individuals that might be interested in depositing content in the repository, right? So the case in point here would be, before you graduate, once you make corrections to your manuscript, in your case, it would be your master's or MSc manuscript, dissertation in this case, because you're doing the coursework and dissertation master's option. What you do is, once you make corrections, you ideally submit that manuscript to DRIGS, right? You put it on CD, you actually print out, is it 3 or 4 copies or something, and then you submit them, right? So what will happen is DRIGS will then, send that copy to the library, and then the library will deposit the manuscript into the institutional repository. The alternative to that is you can, because these platforms, right? Most of these platforms, right, would have a provision to enable somebody to actually log in and be able to deposit the scholarly output, research output on their own. So the option would be to just create accounts for students and then have them deposit this manuscript on their own, and perhaps just put in measures in place so that there's a verification process. So as part of the workflow, before the deposited manuscript is made publicly available, somebody maybe from DRIGS or from the library will verify that the thing that has actually been uploaded is good enough, right? It's of high quality. I don't know what's happening to the UNZA repository. We might as well use Unilast. Somebody just told us to have a DSpace instance installed. So the same goes for Unilast. If you got Unilast, for instance, it's usually like a provision where somebody can actually log in or register something, and then they can deposit these manuscripts on their own. I would have expected people from Unilast to be much more, right, than this is not true. I don't know if our colleague from Unilast is here. this is not true, is it? You can't have 35. In fact, not just 35. You can't possibly tell us that only 8 people have graduated with master's degrees at UNILAS, right? So clearly, same problems that UNZA is experiencing, UNILAS is experiencing. But that's okay. It's like a number of people doing this DBA and PhDs, good stuff. But so the alternative is you'd have people log in and do this on their own. That process is called self-archiving, right? So the problem, number one problem for the UNZA repository is there's no self-archiving in place. All of the depositing has to be done by a unit, right? At the UNZA, it's a unit within the library, right? That is in charge of the administration of the repository. And the unfortunate thing about that unit is that you only have a lean staff complement, right? Last time we checked, there were only 2 people responsible for, not for the ingestion process, but the only 2 people attached to that particular unit, because the ingestion process involves a number of moving parts like creation of metadata and all those things. But anyways, so that's problem number 1. Problem number 2 is the fact that because you have very few people responsible for this depositing of ETDs, there's a huge time gap that exists between when a student actually submits the manuscript, the revised manuscript, the corrected manuscript, and when that manuscript actually ends up into the repository. So what do we mean? If you go to the UNZA repository and you go to the thesis and dissertation community, what you notice when you pay particular attention to the publication dates is that there's a backlog, right? So currently, I believe they are still busy trying to deposit things that were published or manuscripts associated with people that graduated before last year, for instance. In an ideal case, you want this document to be deposited into the repository the moment the student submits it, or at least maybe just a few days after the student graduates, for instance. I'm not sure why this thing is slow, but I wanted to showcase the fact that we're still busy uploading odd things, right? So there's this huge time gap that exists, right? And then finally, there are a number of inconsistencies that we have noticed, right, after conducting a number of studies here. Inconsistencies associated with how these ETDs are classified, for instance, the subject categories or subject headings associated with these ETDs, and it turns out that these issues that I've just highlighted, there are many additional issues here. It turns out that these issues are as a direct result of the fact that this process, the ingestion process or depositing process, is a manual process, right? Most of the things that happen are manually done, right? So for you to identify the keywords, for instance, or subjects associated with a particular manuscript, you have to manually read the abstract and infer to say this content that I've just read is associated with these sort of classifications, for instance. The other thing is the reason why there's a huge time gap is because the depositing process takes quite a bit of time. In one of the studies that we've conducted, we discovered, right? It was discovered that it can take as long as maybe 30 minutes or even an hour, right, to process a single document. And by processing, we mean preparation of metadata, and then going through that submission workflow where you're entering the data, right, or the metadata associated with the document. So this is what I was talking about. For instance, if you look at this thesis here, the way this platform works is it orders content based on what was recently added. You notice we have something from 2019, right, which was recently added, and it makes no sense, right? It makes no sense that you'd have a document that was published, yeah, or a document associated with somebody who graduated in 2019 being uploaded in 2022, 2 years later, right? 3 years later, I guess, I don't know, but it depends on how you're looking at it. So that's a problem right there. I wish I could kind of showcase the submission workflow here, but it's a lengthy process in any case, right? It's too involving, and you can't have two people doing this. In other places where they don't have self-archiving, they'll probably have a significantly larger team working on this, right? And in fact, specialists, so-called specialists in specific domains, right? Maybe in the sciences or in the social sciences or something, so that you're doing the correct things. Anyways, so potential solution to this problem, we're not saying this is a solution and lecture that is meant to cure all problems that we've highlighted, but the potential solution is implementation of machine learning models, right? Supervised machine learning models that would be used to automate some of these activities that are manually performed, or some of these manual tasks can be automated by implementing machine learning models. Yeah. And the idea would be to build models that would be able to help with the classification of things like the type of the ETD or the subjects associated with that ETD. Things like the collection within which that manuscript should be deposited into. Because it turns out that when you log in, like I have logged in right now, I'm logged on, right? When I want to deposit something into, where is that thing? When I want to deposit something into the repository, right? What I would have to do is I would have to, so observe, I would go to provision where I would say start a new submission. I have to specify the collection. So we have a number of people graduate, a number of departments from where people graduate, right? Natural sciences, agri, humanities, medicine, and all those things. The thing is, the first thing you do is you specify which collection this ETD is going to go into. This is a manual process, right? It's a manual process. So what we're saying is we can build a model, right, that can automatically classify a document to say this document is associated with natural sciences, law, or medicine, or mines, or something. It's a not really a binary classifier here, but you'll be building a multi-class classification mode or something, right? So that's one of the things we can do. We also realize that we can actually build a model, a supervised machine learning model that would automatically classify the subject category. So part of what you do as part of this submission process, let's say I wanted to submit a new document in here. As part of the submission process, you go through these steps, right? You describe, upload, review, you specify licensing issues, and then you complete, right? Part of what you do as you are specifying these details here, I'm just going to say period. Okay, just testing here. Part of what you do is you have to specify the, I'm just going to say the University of Zambia here. And you notice, right? I'm skipping some of these fields because this is a time-consuming process. So this is like stage 1 or something. You can view this as stage 1 of 1, 2, 3, 4, 5, 6. So stage 1 of 6. I'll fill in all these details, I specify the type, I scroll here and I say this is a thesis or something, and then I specify the language and all those things. And then I'll say next or something. On the next page is where you specify the subjects. Now, currently, the way they specify these subjects is they'll use open-ended text, right? Use open-ended text. So maybe you'd say machine learning, right? And then you say add. Then something else you'd add here is you'd say artificial intelligence or something, right? You say add. And then as another example, I'd say computer science or whatever, right? Computer science. Now, if you notice, right, I'm going through a manual process of specifying these tags. These tags are the things that you will see associated with the document. When you're viewing these things, right, on this page, you notice that there's this panel that says subjects. So these broad subjects that have the number in parentheses of documents tagged with that subject are used in this way. They facilitate effective browsing of content. It doesn't have to be this way. That's the argument we are saying, right? So you can automate this. You can build a classification model, which is what we've done actually. We propose to build a model, right? A multi-label classification model. You notice here it's a multi-label classification model because you can have 0 or more, I guess it's 1 or more subjects associated with an ETD. Yeah? And then the other classification model that we built was a collection classification model. So essentially just a model that would help us determine to say this manuscript that has been authored is supposed to go into the School of Natural Sciences collection, for instance. Anyways, the question though is, how do we do this, right? Well, we realized that after studying, right, the end-to-end process associated with depositing content, we realized that there is a single source of truth in this workflow. The document that the student submits. So this would be the thesis or the dissertation. So in essence, our source, right? Our single source of truth or the source of data was the PDF manuscript. And as it would turn out, what we realized was that the important information that would be interested in from that PDF document would be the title of the ETD. So the title page, right? This is like specific sections within the ETD, but would be interested in things like the title of the ETD, the abstract, the title page, and the total number of pages associated with the dissertation, and more on that, by the way. It turns out that there's a logical explanation as to why we narrowed down on these specific features, right? So the title, the ETD, the abstract, the title page itself, or at least the textual representation of the title page, and the total number of pages of the ETD. To help you understand this, what I'm going to do is I'm just going to see if we can use I don't know if I have Alinani's manuscript. Maybe we can use this as an example. I should have it. I should have it somewhere, I hope. That's weird. It appears I don't. I was hoping I could. These are all reports, though. I was hoping I had. Oh, there we go. I think it's here. So to give you an example of what we mean here, right? Come on. I don't know what I just did here. Oh, this is page 5. Okay. To give you an example of what we mean, what we're saying is that we identified that in order for us to build these 3 models, right, we had to use the title of the manuscript as a feature, right? This is what we mean here when we're saying we're using the title. So there's the title, and then the abstract, right? So within this manuscript, for instance, you'll notice that somewhere here you have this thing here, the abstract, which is this text, not including the sections, but just this text here, right? This stuff here. Something else we used as input would be the title page, right? So content on the title page. And what we mean here is the very first page, right? So everything that you have here, from the title, the name, the author name, including this piece of text here, it says a thesis submitted to the University of Ghana, blah, 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 blah. It turns out that, and I'll explain more, I think once we look at preprocessing and data preparation or something, as to why we decided to use this as input, right? So the entire text on this page, in essence, was used as a feature. This was a feature as well, right? And then finally, what we're saying is that something else we used as a feature would be the number of pages. Now, the number of pages would be the actual numeric value. If you look at Alinani's dissertation, I don't know if you can see, it's 157 pages, right? It says here 1 up to 55. So if you scroll down at the end here, it's like page 157 or something. So we're looking at the number of pages as well. Something worth mentioning is that we just did not arrive at these features. We had to take advantage of business understanding. And part of the process of us going through business understanding is we held interview sessions with people from DRIGS. We've done this for the last couple of years, at least. A number of projects that have been done centered around this. So we understand this space quite well, it turns out. But interestingly enough, there's certain interesting information that one can get from the guidelines, right, from DRIGS. So if you go to, and I think I have the guidelines somewhere, I hope downloaded, PG. Yeah. If you go to the DRIGS website, what you will notice is that there are guidelines to do with how long a thesis should be and how long a dissertation should be. So somewhere in here, I hope I'll be able to find this, is an outline of how many pages, and I hope I'll be able to find this, but it appears I won't be able to find it. Maybe it's a length or something, right? Right. So in the DRGS guidelines, they will tell you that if you're preparing a master's dissertation or thesis, it must not exceed 60,000 words, right? If you are preparing a doctoral thesis, it must not exceed 100 words, right? So as part of the business understanding process, we were able to realize, to say, well, if this is a case, you can easily translate this into pages, right? I mean, depending on you can come up with an approximation. In fact, in the guidelines, DRGS has specified, right, to say the spacing should be, I'm not sure if it's double spacing or something. So you realize that you can easily approximate. If you say a page is about, for argument's sake, just put it at 500 words, you realize that 60,000 translates to about 120 pages, right? So what we're saying is that if you're trying to classify whether something is a master's dissertation or a PhD thesis, what you could do is you could use as a feature the total number of pages of that dissertation. Because if the total number of pages exceeds 120, it's more likely going to be a master's manuscript. Otherwise, it would be a PhD manuscript. I don't know if this makes sense. If you divide 100,000 words, right? If you divide 100,000 by 500, you notice that you're looking at like a manuscript that is close to about 200 pages or something, right? So this is also done as part of business understanding, right? So in essence, we proposed a solution that would use these sort of features, and we implemented these classification models, right? So this is a solution that we propose. So the question though is, using this proposed solution, I mean, how exactly did we systematically make use of an approach like the CRISP-DM model, which is what we use? CRISP-DM is what we used here. How did we leverage the CRISP-DM to actually work through this proposed solution, right? So I'm just going to try and see if we can tie some of the activities that we introduced during our previous sessions we've held, and then try and tie them to these use cases now. So as a very first step, we underwent business understanding, and if you remember our discussion, there are certain key activities that you undertake as part of business understanding, right? So one of the very first things we did in our case is we were outlining the business and data mining goals and objectives. And in our case, this is simple, right? We were interested in automating this manual process here. If you look at this workflow, we're trying to automate this workflow. The reason is simple. We're doing that so that we cut down on the amount of time spent doing this. The other reason is we're trying to cut down on the number of errors made when you undergo this manual process, when you manually deposit an ETD or you manually classify an ETD. So that was the goal or the main objective of us undertaking that data mining project. And the other thing that we did was to try and gain an in-depth understanding of how the workflow actually works. We conducted the so-called situation analysis, right? In essence, we were trying to systematically identify how this problem could be best addressed. I mean, yes, we had an idea that implementation of machine learning models would be the way to go, but the question would be, how would we do this, right? And so what we did was we held a number of interviews with key stakeholders, so people from DRGS, a lot of interviews with people from the library, right? But also we in the process we held workshops as well. These were mostly workshops where we would invite people from the entity within the library responsible for depositing content to come and give talks centered around how they actually deposit content to the repository. Very useful stuff. And then of course, I mean, for each of these, because it turns out that there were a number of sub projects, right, that were spun off from this broader objective, and some of these things we're still actually working towards here. So we have timelines associated with these sub projects that we undertook, and as Elia mentioned, some of these projects are still ongoing. But the key thing here is if you look at the focus here, right, is trying to focus on business understanding aligned with this project. We set out to identify the data mining goals and objectives, and then also to understand the workflows associated with this manual deposit process, right? So that's business understanding. I don't know if this is making sense here. Feel free to interrupt me if you need to interrupt me or something. I'm hoping that as we are done with these 3 case studies, people have a firm sense of how you typically apply the CRISP-DM model. And in fact, after today's class, you should find it relatively easier to understand the paper reading assignment number 1. Because in as much as the authors will not actually explicitly state to say, this is a data mining model that we used, but in the methodology, hidden in the methodology will be these distinct phases that we're discussing right now. Anyway, the next stage or the next phase was data understanding. Primarily, our interest in here was to identify potential data sources, right? So if you're implementing a data mining model, right? A machine learning model, in this case, is a supervised machine learning models. A key ingredient we've mentioned is data, right? So the question we set out to ask is, where was this data going to come from? As it turned out, as part of business understanding, we discovered that the best source would be one, the actual PDF manuscript prepared and submitted by the student, but also for some models, it turned out that using metadata associated with things that were already deposited into the repository was going to be useful, which it ended up to be useful, especially when it came to actually creating a labeled data set, right? Because when you're dealing with supervised machine learning, once you gain access to the data, the next thing to do is you need to create a labeled data set, right? And then you split it into a training and a test data set or something. Right, so we identified 2 data sources, right? So the PDF and the descriptive metadata. So it's the Dublin core encoded metadata. And more on that, I think I have screenshots showcasing this Dublin core encoded metadata. But in essence, the Dublin core encoded metadata is stuff that looks like, so that people know what we're talking about. So the PDF manuscript is similar to this manuscript by Mr. Simkanga, right? Arinan Simkanga. And then the Dublin core encoded metadata would be the stuff that can can easily be, you can easily pull this information out, because typical, repositories, we implement certain key protocols. There'll probably be a REST API and also an OIPMH data provider. So what we mean by Dublin Core encoded metadata is stuff that looks like this, right? So we were extracting not just the PDF, but this stuff here, right? Yeah. All right. And I'll talk more about this just now, specifically how we're extracting, how we are collecting this data and all that. Oh, and it turns out this is what I'm talking about. If you remember our discussion of data understanding, we said once you identify the sources, right, you do things like you do a preliminary data collection exercise, right, to just test the waters, right, try to sort of like determine exactly how you are going to to collect the data. So you know that the source of these features you're interested in are going to come from the PDF manuscript, right? The question though is, if you look at the UNZA repository, the question you're asking yourself is, out of these, currently the UNZA has about, I don't know, I mean, maybe 4,000 or so manuscripts or something. We can check this here. If you look at this, 4,037 manuscripts. So the question is, how exactly are you going to be, if you're saying the PDF, all these 4,037 manuscripts, right? You're interested in getting the PDF documents. The question is, how are you going to collect or extract the PDF documents, right? Yeah. So that's one question. And also the descriptive information. So this Dublin Core encoded metadata, how do you extract this information? That's a question we set out to answer. Again, it was relatively easy in our case because these tools are usually standards based, right? So there are certain default protocols that are inbuilt in these applications. And for us to gain access to the PDF documents, what we did was we essentially took advantage of the so-called OAI ORE. This is called the Open Archives Initiative. Is it Object Resource Exchange Protocol? It should be. So there's a difference between the OAI ORE and the OAI PMH essentially. So we took advantage of that protocol to enable us, download the PDF documents. But in actual fact, actually, you can come up with the other clever ways of downloading the documents, right? All you have to do is spend a little bit of time on a site like this or in a site like Unilas. We can use Unilas as an example. When you spend time on a site like Unilas, you will notice things like the fact that there's a pattern, right? So if we were to check the download link associated with these PDF documents, what you will notice is that there'll be some sort of a pattern. So I can just maybe download. I don't know if I can just get this. Oops, sorry about that. I'm just going to see if I can get this link here. What you'd notice is that there would be a pattern. So this is a sample document, right, on the Unilas repository. If we go back and look at a completely different, so this is project evaluation of public-private partnerships or something. If we go back and look at some other manuscript and do the same thing, right, where we sort of like check for the download link here, what you'll notice is there'll be like some sort of pattern, right? Again, I'm just going to extract this href attribute, right? You can clearly see here that there is some sort of a pattern, right? That would enable you maybe scrape off that information, right? Perhaps what you'd be doing is going to a page and then just checking for anything with a .pdf or something and just download it if you want to. Or if you're smart enough, you notice that this pattern will have like this resource path where the only things that are changing is this code here, right? This is 156, this is 151. And then of course the name of the file is somewhat different. But you get the point, right? what I'm trying to say is that you don't necessarily have to use fancy protocols like the OAI or a protocol. You can scrape off information to collect the data. All right. But of course, using something that is more structured like a protocol makes life a lot easier, right? Because you don't have to, handcraft scripts. All you have to do is just read up on the protocol specification on what to look out for, depending on what it is you're interested in extracting from here. And then for us to collect the data associated with what we are calling as doubling co-encoded metadata, all we did was we took advantage of the OIPMH. So this is the Open Archives Initiative Protocol for Metadata Harvesting, right? So I showcased how this looks like, right? This protocol will allow you to extract this sort of information here. And all you do really is, using the protocol. The protocol itself is made up of certain types of verbs, right? So there will be a verb that would enable you to list all the records, which is what this is a verb I'm using. There's a verb that will allow you to selectively pull an individual record, right? So there's a get record verb. There's also a verb, an identifier verb, right? And all you do really when you're working with this verb is you just change these parameters here. But either way, anyways, so this is what we did, right? We took advantage of this protocol here so that we could extract this information. And then again, obviously, I mean, for you to be, if you remember, some of the things that you do as part of data understanding is you do this initial exploratory data analysis, right? You're trying to understand the sort of data you're working with. This is almost always the case, but also you do things like, data source selection, right? So it might just turn out that perhaps extracting data, right? This doubling co-encoded metadata would be a bad idea, right? Perhaps we discover that there are a lot of errors, right? And it turns out that for some elements here, we discovered a lot of errors, right? Anyways, so for implementation of certain models, it was a bad idea for us to use this as a data source essentially. But the single source of truth, a manuscript itself is perfect because it has authentic information. All right, information that was prepared by the original author of this document. Is not the case for these things you're seeing here. Point I'm trying to drive at is, if you look at Unilas, we're going to go to Unilas here. What you're seeing here, everything you're seeing here, like the title, the name, the abstract, this was done by somebody else, not the original author. The problem with that is that it's possible that this person would have made a mistake, right? Maybe they made a mistake with the name. Maybe they copy pasted the wrong abstract, right? So what we are saying is that using this single source of truth is perhaps the way to go, because we know that the information we will find in this PDF document is going to be accurate, correct, right? Assuming these people have gone through the institution's verification process or something. But anyways, so a preliminary exploratory data analysis, and part of what we're trying to do is to ascertain the quality of the data. And just to kind of, I think I can showcase some of these things we did. I'm just going to showcase, I think there's still, that data is still available on some server somewhere. Just bear with me. I don't know if it's here. Should be, I believe, I don't know. I wanted to kind of like showcase the data we had collected. I'm not sure if there we go. So I'm just going to, and I hope I haven't deleted some of those things here, but I don't know if I have deleted some of these things. Maybe I have, maybe I haven't. I hope not. Oh, there we go, right? So just giving you an example, right? So So this here, what you're seeing right now, right? All of these things that you're seeing here in here, this would be PDF documents. So for all, in this case, actually, we have I don't know how many documents we have. When we collected this data, we had harvested a total of over 3,000, I guess it's like 3,329. I don't know if this is 29. I don't think these are already converted into text. Probably not yet. So we harvested all the PDF documents, and then because we were interested in things like the title, right? The title page, the first page of the manuscript. What we were doing is for each PDF document, after we did that, we were splicing it. So extracting the first page. This is why we have things like, these cover pages here. So if we were to look at an example cover page here, of course, I can't view this PDF document here. I'll have to pull it, but what I can do is I can do a PDF to text, for instance. PDF. Oh wow, this is strange, right? PDF to text is not here. Oh. Surprised that wow, this is insane. Sorry about that. I didn't know that. I didn't know that this server does not have. Very strange. Doesn't have. But the other thing is because of the nature of what was being done, by the way, the actual implementation. So what we're doing is maybe we'll download and harvest information from this server, but then the actual processing was maybe done on individual laptops or something. So I know, for instance, that I have the text representations of these PDF documents somewhere on one of my external hard drives or something. But anyway, so if I do a PDF to text, for instance, right, of this document, and if I view the text representation, you notice that this is what we're interested in. Now, I know what you're thinking, well, it's poorly formatted and whatnot. Well, the interesting thing is when you're implementing these models, if you remember, and more on that just now, what we do is at some stage, we convert this into a numeric representation that the computer is going to have to understand, right? And really, the computer itself doesn't really mind, it doesn't care, right? If there's this I or something, what you're interested in ultimately is just maybe a TF-IDF representation of what you're seeing here. And then once you feed it into an estimate or the model that you've implemented, it will be able to tell you to say this is supposed to go into the score of medicine or score of public health or score of natural sciences or something. I don't know if that makes sense, right? So that's the cover page, right? I don't know if I have a script here. I can showcase. I'm bound to have a script. I'll be so shocked if I don't have a script that okay. This is very strange. I thought there was it's possible maybe I probably have these on my I don't know, maybe I have these on the other server or something, and then the processing was just being done here. But I wanted to showcase the script essentially that was used to kind of like extract the PDF documents. But either way, that's okay. All right. So a preliminary exploratory data analysis, you're trying to ascertain the quality, and there were a couple of interesting things that happened. By the way, the preliminary analysis, right? During our preliminary analysis, we discovered something really interesting about the PDF documents. We discovered that at some stage, the UNZA, if I'm just going to see if I can order these by size, right? Sorry. I'm just going to order these by size and try and see if I can go to here. I'm just going to order these by size here, so that there's a point I'm trying to prove, right? What we discovered was that, and I hope this example we'll be able to discover this example. I want to find, come on. We discovered that there were certain, and I think it's a classic example here. at some point, what the UNZA was doing, because they didn't have born digital documents, right? So things like this is born digital because you can copy this text, right? This was created electronically. What the UNZA was doing at some stages, they were scanning these documents. And because these documents were being scanned, you'd find that the quality of the scanning was really a bit problematic, right? So your default OCR, like your optical character recognition process, wouldn't really work here, right? So if you use like your normal conventional tools to actually do like optical character recognition, you'd end up with gibberish. And I hope I can showcase some of these examples here. If I do a PDF, a direct PDF to text here for this document, and I'm hoping, actually what I'm going to do is I'm going to see if I can pull this document, by the way, to my computer. So that we're able to appreciate what's happening here, but that's okay. I'm just going to pull this 9 megabyte. So the reason I'm putting this 9 megabyte file, by the way, is because you can't have just one page, right? This is just one page. It makes no sense for you to have a single page that is 9 megabytes in size. It does make sense though for it to be like maybe a few kilobytes in size. You understand what I mean? So it's likely that this thing was scanned actually, right? So I'm just going to pull this and see if this was actually scanned. We can actually do a couple of other things, like we can pull this 2225. We can actually pull it from here as well and view this, right? So it's 225. You can view this document and see when it was published. And what I'm showcasing is a classic example of you assessing the quality of the data, right? You'll notice this is like a 2011 document, at least says the date is 2011. And you can see from this thumbnail here that this was likely scanned, right? Insane, right? 44 megabytes. That's the file size of the entire document. What I'm going to do is I'm going to see if we can maybe download this document or something, and it's downloading, and then we'll see it actually. And I think this cover page, I don't know what's happening with my connection, but maybe it's the server itself. There's no way a 9 megabyte file would take this long. But once this is done, once this document is done downloading this Mbamba document thing here, you will appreciate the point I'm trying to put across here. The fact that as part of the process of assessing the quality of the data, we realized, right, that there were a significant number of documents that were actually scanned. They were not born digital. And because of that, getting a textual representation from a scanned document posed some sort of a challenge. And that's the point I was trying to drive at here. I don't know why this is taking long. But also what we can do is, as I'm downloading these things, is I don't know if I've already done the PDF to text here. I'll do a PDF to showcase what I mean here. PDF to text of this scanned document, and I'll view this. If I try and view this, surprise, surprise, right? Empty, right? There's just this special character here that says L. And the reason this is like this is because, like a normal PDF, because the nature of the algorithm associated with PDF to text, I guess, because of how the scanning was done, it's an image essentially, right? You can't extract any text, not directly anyway, right? And there were a lot of such documents. I think there's a paper where we talk about these things, right? So anyways, long story short, I will revisit these other documents once the download is done here. Notice, I don't know why, maybe it's a UNZA repository here, but I would have really loved for us to see the way the scanned document looks like. But long story short here is that we're doing that to ascertain the quality. We're only able to discover all those things as part of the initial, exploratory data analysis, the part of the information that we had extracted. I'm not sure if this is making sense or if people have any sort of like thoughts or additions about what we're talking about. I don't know if you're able to piece the different pieces together, how this links to some of the things that we discussed in the most recent class, for instance. I don't know. Thoughts about this? No?
Dr. P. Dr. P.
Yeah. Yes, sir.
Yeah, you mentioned about the abstract being copy and pasted, but how were they doing the copy and paste for the non-born digital documents?
Oh, because so great question. Because you see, you'll be able to understand that if you understand. And this workflow, by the way, I'm not sure if this is it applies to Unilas, but I know this applies to UNZA. This is how things operate at UNZA, right? So here's what happens, right? There's a couple of stakeholders here. You have student, you have DRIGS, well, I guess one would argue the supervisor or something, or supervisors, right? DRGS and the library, right? So student will prepare a manuscript, right? Yeah. And then submit manuscript to DRGS on CD, right? And physically. They'll tell you, submit, is it 4 bound manuscripts or something, right? To scratch the supervisor. We're just assuming this is after the supervisor has revised the work and whatnot. DRGS, right? At some stage, DRGS will compile manuscripts. At some, I don't know how often they do this. They'll compile manuscripts, maybe after students graduate, they compile manuscripts and then send manuscripts to library, right? And then the library will then use CD to prepare metadata. Now, when you're preparing metadata, you open that CD, for instance, right? And then once you open that CD, when I was saying copy pasting, you'd be copy pasting. Where's that thing? You'd be copy pasting. Come here and you copy this abstract. You copy it and then you'd paste it as part of that workflow when you are specifying the abstract, for instance. So the title, just copy paste. Now, the thing here is that when the institutional repository was set up, right, UNZA had this backlog of dissertations. The thing with the backlog of dissertations is there are so many uncertainties. If you're submitting this dissertation on CD, you know that, I mean, the CDs have a lifespan, right? CDs become scratched. Depending on how you're storing them, that data will become unreadable. But there's a backup. What is that backup? The bound documents. If you go to the UNZA library, right, the special collection or whatever, I think it is, you can find any document that was produced at the UNZA from the time the UNZA was opened. I don't know if you know this. So if you don't have anything on CD, what you do is you go to that location, you get that manuscript. And so what the UNZA was doing is they had funding and they had this massive digitization exercise, and I think it's still ongoing, where they would get the physical copies, the things that the student printed, and scan them to convert them into digital form. Because you are scanning, that is not born digital. So you cannot copy and paste that. So what you do is, and thank you for asking that question, you get that scanned document, and then you have no choice but to start typing, right? You are reading. As you are reading, you're typing the abstract. You understand this? I don't know if this makes sense. So you, and I guess you should appreciate why maybe it took long for UNZA to actually, for UNZA to actually catch up on that. And I don't know how far they've gone with the digitalization, but some of the analysis we've actually done in the past, right? We actually have publications about this. Is you notice that there's a bit of unevenness, right? If you really look at the the ingestion of data, you notice that at some stage there was a lot of stuff that was ingested into the repository, and you can see this from the UNZA repository, by the way. If we go to, let's say, if we go to, if you just go to thesis, right? I'm just going to go here and just go to, I don't know why this is taking long, but something wrong with this server, I guess. I don't know. if you look at the if you look at the panel that showcases the years, right, when these things were uploaded, observe, you notice that okay, this is date issued. This might, is it date issued or date published? I think it should be date issued. If you try and compare the years, right, you notice that, oh, wait a minute, why is it that between 2000 and 2009, how can it be, does it make sense? Do you think it makes sense? You see the unevenness, right? I don't know if this makes sense. So there's a massive digitization exercise here, right? Prior to a certain period, we didn't have, or at least they did not have born digital documents. And by the way, some of these things we're talking about, they're easier solutions, right? Like for instance, when a student is graduating, create a simple form and have the student submit the dissertation online, right? Or as part of SIS or whatever tool they're using now, as they're graduating, tell them to deposit the document, right? Using that application, not on CD. We know that putting things on CD is a bad idea, right? CDs become scratched. The verification exercise is difficult. Maybe the student will make a mistake and think that they've actually burnt their dissertation on CD, but that CD will be empty, right? And as such, you're forced to scan the document. But either way, so that's the data understanding part. And then came the data preparation, right? And again, as we're talking about this, I want you to just think about some of the broad spectrum of activities that we perform as part of data preparation, right? Data cleaning, if you remember that, depending on the type of attributes you're working with, maybe preprocessing might be necessary, right? Things like handling of null values. I don't know if you remember those things. But it turns out, right, if you look at the features we were working with, title, abstract, contents on the title page, this is text, right? And because we're dealing with text, the normal preprocessing activities associated with text are the ones that we heavily used. I don't know if you remember our discussion of case forwarding, for instance, right? So normalization of cases, right? If you look at the text, typical text, again, if we can latch on to Mr. Alinani Simkanga's, some will use lowercase and whatnot, so you want a bit of consistency, right? Why do you want consistency? Well, if another student specified their text where there's Zambia in title case, for instance, you will not have a Zambia in uppercase, right? Once you transform the data, it will be as though the Zambian uppercase is different from the Zambian lowercase. We discussed this, so which is why we did case forwarding, case normalization, the usual stuff like removal of stop words, right? So things like is and a, you remember those things. And interestingly enough, right, there were certain hyperparameters that we used by taking advantages of the libraries we were using that removed words that we can classify as stop words specific to Zambia, because these ETDs are to do with Zambia. If they are to do with Zambia, you agree with me that the word Zambia would be a stop word, right? It will have no value. You understand this? And more on this, by the way, during our discussion of preprocessing, we will see exactly how we do this using code. So obvious things like the removal of what is that? Removal of punctuation. So again, if we go to Alinani's dissertation, right, this apostrophe, right, is Zambia's Food Reserve Agency, right? So what we were doing is we come here and we say, maybe you do your case forwarding, it's like Zambia, right? This is a punctuation, right? So we remove that, and it gets even better. I mean, you may not have a lot of punctuations in your title, but you certainly have a lot of punctuations in your abstract. Yeah, you go to your abstract. If you go to your abstract, you will notice that there's a whole bunch of punctuation marks here, right? Parentheses, whole bunch of them, full stops, commas, semicolons, full colons, right? Hyphens, all of these things, you remove them because they have no meaning, right? And scratch that. For the purposes of what we are doing, looking at the tokens we are working with, for this project, the token we're looking at is a word, right? If we're using a sentence, maybe a full stop would have some sort of meaning, right? A comma might have a meaning, but we're using a word. And because we're using words, we had to remove all these punctuations. Not only that, because of what we were, oops, I just accidentally closed, I don't know how I did that, but I just accidentally closed, a whole bunch of things here, but we can always reopen them, I guess. You can always reopen Mr. Simkanga's dissertation as well. I guess even better, I mean, some of the things we might want to remove, not just punctuations, but numbers as well, right? I mean, think about this for a second, right? There was a weird way of Mr. Alinani of specifying the objectives where you're numbering the objectives. But this has no meaning, the 1 and the 2. So you remove these numbers and punctuations and all those things. And then obviously removal of duplicates, right? And I'm guessing you're thinking here, but what sort of duplicates are you talking about? Well, again, because this is a manual process, what we discovered, right, during our preliminary analysis is that there were certain things that were duplicated. If you're looking at the thesis, right, we're in the thesis collection here. There's no way you can have one person submit 4 manuscripts at the UNZA. I mean, I know there are people that are really obsessed with school and, you know, they'll have 10 master's degrees, right? Surprisingly enough, from the same institution, but why? 10 master's degrees and a PhD or something. But ideally, right, would become suspicious when we start looking at things like, why is it that this person, Lilian Chipatu, has 4 manuscripts submitted? 2 makes sense because maybe Lilian did her master's and PhD at UNZA, but 4, I don't know, right? So we need to identify if there are duplicates here. And true to that, I think Dr. Chipatu's case is classic, right? Look at this. If you look at, oh, this is interesting. If you look at this entry here, the second entry, it's the same as this one. So this is a duplicate, right? Entry. In fact, one would argue that there are 3 duplicate entries for this entry. There are 3 entries for this same thing here. I think this was her, I know Lilian did her PhD recently. This would have been a PhD, I guess. I don't know. But you get the point, right? So removal of duplicates, right? And a few other things, really. I'm trying to see if this will come up again. I think in the code, the source code that we share, when you start looking at preparation and pre-processing, I think we use this particular use case as an example. So more will come up. But in essence, I was just trying to showcase here to say, the process itself, the data preparation process, in part involved us cleaning up the text data we're working with. Is this making sense? It was supposed to have been just an example here of what we just spoke about. I guess I mixed up data understanding and data preparation, but that's okay. Just trying to showcase to us some like examples of. I mean, some of these things I've already showcased, right? The data sources. So we have the cover page here, right at the bottom, just showcasing the content of the cover page. And then here we have like Dublin Core encoded metadata. Something else we discovered as part of business understanding was that there were certain things that were, uploaded, certain ETDs that were uploaded in a very strange way, right? So you'd have multiple PDF documents associated with the same manuscript. The reason they were doing this is at some stage, the way they were uploading these documents was you'd upload, you have the cover page, then the main body, right? Which is really weird, really, if you ask me, right? Main body, God knows what else. I wish there were examples we could use from here. So you have the cover page, the main body, and the preliminary pages, which is a bit weird. And so this was quite helpful for us because the preliminary, data collection exercise taught us, right, or guided us on how we would handle this. And so some of our scripts were created in such a way that we would merge these documents, right? You merge them so that you recreate the entire manuscript, right? Or actually, a smarter way of identifying which of these 3 documents is a cover page. Well, you just look at the size. The merging was done in a different project. But so if you have multiple documents like this, right? The main body, the cover page, and preliminary pages, how do you know which one is a cover page? Well, a cover page is only one, right? Preliminary pages would be a lot of them. So the one with the least size is your cover page, obviously. So this is like another technique that we used. I wonder if I can showcase an example here. I don't know if I can showcase an example where we had multiple pages here. I'm just going to do a grep for 2.pdf. Nothing. Okay, I'd already gotten ones here. Okay, I wanted to see if I could get the other pages, but it appears it won't. That's okay. I'm sure it's on a different server. But I was looking for a unique case where you had like multiple PDFs. I imagine we could be able to find these things. As we're looking for this, I don't know if there are any, as we're looking for example that I want to showcase, I don't know if there are any thoughts about this or comments that people might have or something about what we've just discussed just now. Okay. Trying to see. This is very strange. We have one document which is in French, apparently. Wow. I'm trying to see if we can get to. I'd like to think that the earlier documents probably had the ones that were scanned earlier probably have multiple pages. Nope, not this is just one. How about this? I wish there was an easier way of. I really wanted to highlight the example I was talking about, but it appears. It appears this would be hard to kind of like identify, but that is okay. That is okay. Okay, that's okay. But anyway, so in essence, I mean, so we get the PDF in this case, but remember what we're interested in is a text, right? So we'll be getting actually the text representation from the cover page. So that will be everything you're seeing here, like this part that says a cross-sectional study of factors contributing to moderate severe post-operative pain after laparotomy. Wow, fancy. Anyways, and then the text representation of preliminary pages as well. And then what we're doing is also getting text from here, right? Dublin co-encoded metadata, right? Anyway, just to showcase I think I've already showcased an example of Dublin co-encoded metadata, but it's quite easy, really. It's a web service essentially. I mean, similar to how you would extract data from a RESTful endpoint, if you will. And true to that, I mean, if you actually go to if you just pick this, for instance, and attempt to, I'm just going to open a new document here. I don't know if I can use wget here, but maybe I can. I don't know if wget is the appropriate thing to use here, but yeah, I would tend to get wget options here. I don't know why, but I don't know if I can do. There you go. So something similar to what you just seen here, right? And I guess one would say XML linked. I don't know if you can format this. Yeah, I tend to forget how to use these things, right? I don't know. I think I need a manual. It's a format. Probably need a manual on how to, an offline manual, I guess, instead of doing Google. Essentially, I just wanted to showcase to you to say what you're seeing on this web interface, right? I just showcase just individual metadata. But when you create a script, what you'd be seeing is like metadata for each record, right? So if I was to, yeah, it's format still. So if I was to, if I was to showcase this, right? This is what I mean. I don't know why this is taking long. It shouldn't take this long, is it? Oh, wow. Maybe I should have exported it to an external file and then, I think there's something wrong with this server, but okay, that's okay. It's, maybe we're looking at the wrong way of doing this. That's okay. Oh, there we go. So this is what I was talking about, right? To say, if you look at this, right? This is XML encoded, right? It's the beginning of the response itself, and then you notice that you have this tag that says list records, and then each individual record will be wrapped into this record tag, right? So what we are looking at from the beginning of the tag until the end of this record tag is one record, right? Beginning of record, end of record. Beginning of new record, and then somewhere at the bottom is end of new. And so you essentially extract this information and then identify which of these metadata elements you'd be interested in. In our case, because part of why we did this is we're looking at creating a labeled data set automatically. So we use this information to implement a collection model, for instance, right? So we were in fact interested in the so-called set specs, right? So at the top of this record thing, you'll find something that says set spec, right? The set spec will tell you the collection or community or collections where this thing sits in. So this code here, these codes here will correspond to, right? If I come here and go to sets here, these codes here will correspond to these things here. So all we'll be doing is just, again, as part of your script, you just do a simple lookup to say for each record you're parsing, you're identifying where this is coming from. So we see that this ETD, we're looking at this first one, not the second one here, which has the title, Instruction-Based Formative Assessment in Selected College of Education in Zambia or something. This belongs to the School of Education, right? This is the code here. Just search for this code here, -76, -76. -18 is -18. -18, where are you? -18 is the community code pieces and dissertations, right? So you have to do this, and somewhere at the bottom, if you wanted to find something else, -76. I don't know if it's the same thing, still same collection, maybe. We tend to have a lot of people that graduate from certain schools, like School of Education or something. How about this integration of gender and whatnot? This is -2, right? If we search -2, you'll notice that this thing is coming from, okay, still, adult education and extension studies. But you get the point anyway, it's neither here nor there. So this is why we got the Dublin Core encoded metadata essentially. Key point here is two sources, and we're just showcasing examples of how this data was extracted, right? And then again, just to showcase, remember I said we use the ORE protocol, Object Reuse Exchange Protocol, it's called, to extract the PDF. Well, if you look at the thing that we get back, right, when you use the ORE, part of what we see here is, I don't know if this is there, but part of what we see is, where is the PDF? There's a link to the PDF, right? I don't know if you can see this here. This direct link is what we were just solely interested in. So we'd use this direct link to just do, like, you can do a wget, I guess, or whatever fancy tool you prefer to use to just download the PDF document, right? So we'll download the PDF document. And then once we downloaded it, obviously the next step was to get the section of the document we were interested in. In our case, page 1, the cover page, right? And getting the cover page, obviously, it's a trivial task. You're just cutting off page 1, right? The utility tools you can use. What we find quite effective in most of these projects we work on is tools like PDFTK, for instance, right? When you just say, give me page 1 or something, because page 1 is going to be a cover page. So we get page 1, and then you label it accordingly, right? So what you are seeing here is just a snapshot showcasing the page 1 and the corresponding PDF text version of page 1. So after we got to page 1, we're converting it to text. And I think I showcased an example there, right? And then remember we had said that here at the beginning, we had said that something else we're doing is extracting the number of pages, right? So if the thing is, if you have a dissertation like Alinani Simkanga's dissertation, how do you get the number of pages? Well, I'm sure there are fancier ways, right? How do you automate this process? What we did ourselves is, again, utility tools like PDF Info will give you metadata about that document. Really useful utility tool, but of course it's garbage in, garbage out. Some of the things are automated, right? Like the pages associated with the PDF document. So observe, those of you that haven't used this yet, if we go to Mr. Alinani Simkanga's dissertation, right, which is reports.alinani.pdf or something. If you run PDF info on this document, it will give you this output here, right? It will show you what tool Alinani used to create this PDF, when that document was created. And some of these things might be useful for other use cases, but in our case, the only thing we're interested in is what? This metadata element. And this is the stuff that you tend to see when you go to file and then you say properties, right? Using your favorite PDF tool, you will tend to see this stuff here, like the file size and number of pages or something. So in our case, we're interested in this 157. I know it sounds crazy, but that would go through such lengths to get this information. I'm not sure if people would have like smarter ways of collecting this data. This is what makes, I guess, data mining interesting in some instances. Some people would tell you to say, listen, Lighton, instead of using this so-called OIPMH protocol, I will write a script that will scrape off this information. That's fine, right? That's fine. And these are the decisions that you come up with as part of your preliminary data collection exercise, right? That you conduct during data understanding, you know? So you prepare the scripts and then you have this information or something. So we would get, and really getting this information is not that hard, right? So you'd come to, for each document, you can write a script, right? You say for each document, do PDF info like this. And then what you do is just grep for pages, right? When you grep for pages, you just get this output here. And if you want, I mean, you can do fancy things like, I'm sure there are things that you can, maybe you can export this to, what do you call this? A spreadsheet and then do analysis from there. But you can also run simple, I mean, you can use simple utility tools like, I don't know if you can print everything. There we go. One, yeah. So you can use your simple utility tools like this, so that, like in this case, I'm just saying I'm going to use a PDF, info to, just grep for pages and then get the total number of pages, which is 157, right? And this you can easily do, because what we were interested in, insofar as this particular feature is concerned, is just getting this number here, this numeric 108 or 157 in this case, or 200 or whatever, right? Because this would tell us whether, and I wonder if we can maybe download Lydian's dissertation as well. I thought it was somewhere here, but that's okay. It's gone. I wanted to use it as an example because I think one of them is one of Lydian's dissertations is actually or one of the manuscripts is actually it's a PhD. So if it's a PhD, it's bound to be lengthy or something, right? I don't know. I hope this won't take long. I don't know how many pages this was. The reason why perhaps scraping would not be a good idea, sometimes inconsistencies, if you notice this particular, I mean, the policy that the ONSA has in place is not consistent when it comes to naming the file, right? So you find some people name it 123, some people name it their name, which is quite sad. Ideally, you can, configure this application so that maybe you name it using these codes that uniquely identify the file or something. But I don't know. This is taking long, but I don't know. Anyway, so we get the pages like this, right? At some stage, when we were creating the multi-label classification or the multi-label classifier or multi-label classification model, what we did was we had to take advantage of so-called transfer learning, right? So we harvested data from PubMed, right? So this screenshot is just showcasing data that we got from there. The beauty is this location, this repository, has been set up in such a way that they meticulously tag information, which is why we used it as a way to take advantage of transfer learning. Anyway, and for a specific collection, this is content to do with medicine and vet, right? I don't know if this is kind of like making sense in terms of, or just showcasing what we did by way of identifying the sources and getting data from these sources, right? As part of data understanding. I don't know. And then obviously as part of data preparation, the cleaning up process, right? So selection of the data source, obviously at this stage you'd have selected the data source, you clean up the data, and I already mentioned the things that we did, stemming or lemmatization, stopword removal, and all the good stuff associated with text preprocessing. And then obviously at some stage, because you see, we are creating a model that takes in all these different features, page numbers, title, abstract. If you remember what we were saying for the business objectives, right? We said the input features were what? Title, abstract, number of pages, cover page text, right? All of these are features. So the thing here is, if you remember our discussion of experimentation, at some stage, right, when we were building these models, when we were evaluating them, we would have to check, and I'll call these T, A, P, and I'll call this C. When we're creating this model, we'll probably create a model. We'll create a model using T as a feature, using A as a feature, using just P as a feature, using C as a feature. A model using T and A, right? A model using T and P, right? A model using T and C, you understand? A model using T, A, and P, right? You get the point anyway. So for you to be able to get to a stage where you're doing this, right? You're experimentally checking these different combinations, you need to merge the data sets, right? And if you remember our discussion of the CRISP-DM model, the reconstruction, the merging, and the derivation of fields is done as part of data preparation. right? So in fact, if you look at our pandas data frame, right, at some stage, it was a data frame that was strung together using all these different features: the title, abstract, text from the cover page, a number of pages, which is a numeric variable, right? So this is stuff that we did. And then I'm trying to see here, no reformatting was done here, and I'm trying to see if maybe the numeric data types were reformatted in any way. Not quite, but it may become necessary sometimes to normalize the data, right? So that maybe instead of having a range from, remember we are saying these cover pages can have 100 pages, 200, 199. Perhaps you might want to normalize them so that you're working with the range 0 to 1, right? So you normalize them that way. But we didn't do that. It wasn't really necessary anyway. We reconstruct the data set, right? And of course, besides the reconstruction of the data set, your final output of this data preparation stage, right, or phase, has to be data that the estimators are going to be using, these algorithms will be able to make use of, right? It's usually numbers, so you transform them. And in fact, it turns out that the next topic, we start off by looking at the different types of data types and techniques that you use to transform them, right? So what we're showcasing here is a couple of things here. Number one, the text, like what you're seeing in the background here, is transformed to this, right? This is a bag of words model, by the way, but this could easily have been a TF-IDF representation, right? And then what this part of the, if I can just go here, I guess, what this is showcasing, this, I don't know what happened to my text. This thing doesn't, maybe I'm thinking about something else anyway. I wanted to showcase, that's okay. Yeah, so this part here, right? I don't know if you can see my mouse, where we have file, dummy, number of pages and whatnot, and identifier. This would, I was just showcasing how we strung together all the different attributes we were working with, right? So the pandas data frame that we had ultimately had this sort of information. I mean, some of this obviously be useless and whatnot, but you get the point, I guess. All right, so this is the final output where you have the data transformed, right? Of course, you discover that numeric data types don't have to be transformed in any way. They're already numbers, right? Text like this would have to be transformed into some representation, like a bag of words mode or something, or any other fancy word embedding that you might want to use or something. I don't know. I can't quite remember if let's see. So the things like the collection name, and there's no example here, but the collection names, right? You'd have things like, by the way, this is 211 pages. I don't know if you can see here. This thing here is 211. This is it's a doctoral thesis, right? It's a doctoral thesis, which is quite, yeah. But I was about to say this shouldn't be a period after the year, but that's okay, I guess. Yeah, I was trying to, what's my train of thought here? What was I trying to, forgotten what I was trying to showcase here, but, oh yeah, I was trying to showcase the, if you go to your dissertations, right? If you go here, under thesis and dissertations, the data that we're working with, these were the labels, right? So that data frame I keep talking about, right, was meant to have like a column for tools. Right? Now, because these are categorical attributes, they have to be converted in a certain unique way. Right? And we discuss how you do this. This is one-hot encoding. So you would find yourself, I don't know if we already discussed this, but we will discuss this. So we will discuss this later on, but the representation that you would be working with would be, what I was trying to say is the data frame you will see from the examples will have things like this, right? Initially, it would be similar to what you are seeing here, and I'm just going to create a spreadsheet here so that you hopefully understand what I'm trying to put across here. But you would initially you start off with something like this or something. I can transpose it, I guess. But what you ultimately why is this specification then transpose? Wow, I don't know why this is not working. Maybe because it's still loading or something. Yeah. So ultimately, the data frame would have things like this, right? Right, where for Lydian's data set, for instance, would be like 0. For Lydian's 0, 0, 1, 0, 0, 0, 0, because she got this. She got her. She did a PhD with the School of Education or something, right? So it's actually quite a. It's quite a long. What do you call this? A very long data frame, right? A very long data frame with a lot of fields, but that's okay. That's okay. I'm not sure if there are any thoughts. I mean, before we just go on to just briefly talk about the model implementation itself, feel free to interrupt me if you need clarification on anything. The implementation, I've always thought, is probably one of the easiest things you ever do, right? Because unless if you're one of those people who is really doing some really mainstream computing project where you are proposing a completely novel algorithm, right? In which case you'd spend a lot of time here. But for most applied data mining projects, you'd be reusing models that already exist. So your task is just to identify appropriate estimators or algorithms, and then you experimentally determine the one that you're going to settle for. Those are the things you do there as part of model implementation. So just to give you an idea of what we're doing when we're implementing these models, obviously, is identifying the different components, right, and features and how they behave, for instance. So important things we're doing here is checking, right, which feature combinations are the best. Title only, abstract only, pages only, cover page only. Title and abstract, title and page numbers, title and cover page and abstract, and all those things. And then also the effect of the estimators, right? Stochastic gradient descent, naive Bayes. I'm not sure if that's a question, but no, I thought I heard a sound or something. So you're just evaluating different estimators, because the goal here is you want to arrive at a model, at the best performing model. You understand this? And in fact, you actually do start your evaluation during model implementation. I've always thought, the evaluation, or at least effectiveness evaluation, is in part done during model implementation. But of course, certain types of evaluation strategies, like if you are looking at evaluating the usefulness of what you've implemented, you'd be doing it after you're done with the implementation of the model, right? So these are things that we did, and just to kind of showcase the different things that we're doing here, right? Evaluating the things like feature combinations, right? If you look at the results we are getting here, If there's anything you want to get from here, by the way, like look at the top right here, where you have feature, focus on the accuracy, right? When we use the title in isolation, the accuracy of the model, in this case, this particular model, I've forgotten which model this was 30%, right? 30.3%. The abstract alone yielded 47.8%. When we combine the title and the abstract, we get 54.2%. It's a subject model, multi-label classifier. When we combine the title, abstract, and mesh, we get 81.7%. I've forgotten what this model is, bottom left. When we look at just the ETD title page, right? The title page itself, we get, I think this is a binary classifier for classifying whether it's a master's or PhD. When we just use the title page, the text on the title page, this text here, I can find what I'm looking for. This bottom part here where we have the by Ushman, BSc, and whatever. When we use just the title page, we get 99.1%. When we use the number of pages, remember we were counting the number of pages, this 157, or if we look at Lillian's dissertation here and extract. Oh. We extracted 211 here. We use the number of pages, we get 97.1%. When we combine the title and the number of pages, it's like the title page and not just the title, but the title page and the number of pages, we get 98.5. What does this tell us? For this binary classifier, the best feature combination to use is you just use the title page, right? So this number here, using the number here doesn't help in any way. The accuracy, I mean, it's in the 90s, but it's far less than just using the contents on the title page. I'm not sure if this is making sense to people, but I thought we'd kind of look at that. And then I think what you have on the bottom right is the collection classifier, right? So the model that automatically classifies whether something should be put in agri, in education, in engineering, in GSB, in law, or in medicine, or in mines or something. Well, it turns out if you just use the title, you get 60.5% accuracy. If you use the abstract, you get 80% accuracy. If you use the title and the abstract, you get 80% accuracy. You understand this? So you see here that you can't choose the title. You're better off just using the abstract or a combination of the title and the abstract. You know, by the way, the reason why the accuracy is quite low here is because we are really looking at classifying. There's a couple of factors here. The fact that some collections are fewer, they have fewer ETDs in them, and also the fact that some of these fields are closely related. So you will find that research done in agri is similar to what is done in medicine. Research done in mines is almost the same as that in engineering. I mean, mining is a form of engineering anyway. If you look at some things done in natural sciences are similar to engineering, like computing, right? One would argue it's an engineering discipline anyway. But that's fine, right? So
I have a question.
Yes. Yes.
Where you get the accuracy being the same, like for the ETD, for where we only use the abstract, and the other one where there's title and abstract, how do you pick which one should be the one to go for?
Yeah, great question. I mean, so what you do is you'd look at, because there are usually other metrics, and it's quite ironic here that you look at precision, recall, and F-score, they were all the same. And I'm wondering if there was something wrong with the way this was done. It's possible that, you know, when we were running these experiments, maybe we thought we were combining title and abstract, but it was still just abstract. But what you do is you look at these other metrics, right? What is the precision score? What is the recall? But also, this is where intuition comes in, right? So I would go for a feature combination that uses a hybrid, right? A combination of both than using one in isolation. But that would also depend on whether you'd require, you know, additional computational power when you're combining, you know, these two things. In the case of a title and an abstract, your average title will probably be like less than 500 characters long or something, right? I guess. I don't know. So less than 500 characters, I think. Can't be more than 500 characters. And so you'd go with maybe a feature that combines two different attributes. Yeah. But the ideal case is you look at these other metrics. And the other metrics that we're going to look at, you gain an appreciation of why maybe it might be important for you to consider precision and recall and whatever fancy metrics that you're using. But you'd look at maybe other metrics, and if they're still the same, then you go for a hybrid, in this case, title and abstract. I don't know if that answers your question.
Yes, it does. Thank you.
All right. So, and then the evaluation, right? If you remember, what you're doing here is you're evaluating this against your original data mining goals. More importantly, and this would in part look at things like effectiveness for the most part, right? How accurate is this model, right? So here's the thing, right? If you came up with a model that's 30% accurate, you'd sit there and you'd be asking yourself, well, is it really worth it, right? Should we actually do this? Or maybe we're better off just continuing off with a manual way of doing things, right? In some instances, you are better off just doing away with the model that you've implemented. Like imagine you are working in the health sector, right? You're building this model that is meant to automatically detect whether someone has tuberculosis or not or something. You don't want to use a model that's 30% accurate, right? You just say, you know what, let's just continue doing things the manual way or something. But in this case, this is a multi-level classifier we built. And it turns out for the multi-level classifier, 30 is not that bad, right? Because the evaluation takes into account, you're looking at all the automatically generated labels, right? You're looking at them holistically. So what the 30% would mean is that there are some labels that would be okay, whilst others might not be okay, which is fine. So but the key thing here is the evaluation. We'll look at the original data mining goals, right? Why you set out to do the evaluation in the first place. And then obviously as part of that, also you look at the different evaluation aspects, right? Are you interested in evaluating the efficiency, the effectiveness? It turns out for what we were doing, these are all offline models. So efficiency is a non-factor. With offline models, you implement them once, and the only change that happens is maybe a couple of months, if not years down the line. In the case of the way we implemented these models, they're supposed to be refreshed once a year at least, because this is when we expect UNZA to update their repository or something. So there you go. And then, so if you remember, what you do is you'd be interpreting the results, right? Is it worth us deploying the model if it's 30% accurate, if it's 60% or it's 80% accurate? Yes, no. If no, then you don't deploy, obviously. If it's no, you loop here, right? You check your business goals here. Maybe you identify alternative data sources, which, by the way, ladies and gentlemen, is what we did here. The reason why we have this feature that says title, abstract, and mesh is because we had gotten to a stage where we are getting 54% accuracy, right? Not good enough. What do we do? Augment the data, right? And then finally we go to a stage where we had like 81.7% accurate. So, I mean, just some graphs showcasing the results. So a graph on the left is just the so-called confusion metrics, right? It's showcasing the for the collection classifier, right? It's a multi-class classification model. You have the accuracies for each collection. So what we're saying here is, by the way, ED is education, MD is medicine, NS is natural sciences, AG is agric, HS is humanities and social sciences, LW is law, VM is veterinary medicine, EG I think is engineering, MN is mining, LB is a library, ID is Institute for Distance Education, right? So what this is showcasing to you is that this diagonal, values in the diagonal, the ones that are shaded somewhere here, are showing you the relative accuracy of the model for each of those collections. So if we wanted to automatically determine which collection, a thesis like the one that Lillian authored, wanted to determine how accurate we will be by automatically determining where this should go, would be 82% accurate. So there's an 8 out of 10% chance, there's an 8 out of 10 chance that we'll do the right thing, which is good, right? And so the key thing I wanted to point out here is that for these accuracies, there's sort of like differences in the different collections, right? Some collections are more accurate, like medicine is more accurate, NS is probably the least accurate, right? And mining, engineering also, you know. So there you go. The cool thing about the solution that we devise is, it's not like we're saying do away with the person who does the manual tagging of metadata. We're taking advantage of what's commonly referred to as a human in the loop intervention, right? Where you build this model, but you still involve a human being. And really the human being, if you look at this workflow we started off from, right, in our case, this workflow, the human being would come up, say, once the models are applied, right, you do automatic classification, the human being will come in and verify, is the classification, does it make sense? Are the subject making sense, right? So you're just verifying, you're reviewing the stuff that has been done, essentially. I mentioned that, you know. And then what you have on your right, is your typical rock cave, essentially. You apply this to a binary classifier. The thing to take our point from a rock cave here is that the curve with the largest area under a curve is what you go for. So in other words, would go for the logistic regression, the LR here. Notice this yellowish line here up here. It's probably the one with the largest surface area or something, right? Just a visual representation showcasing, you know, the fact that after you compare different estimators, you're going to set off for logistic regression because it's the best performing model, essentially. More on that, we have an in-depth discussion of these common metrics, right, or evaluation techniques. When you're dealing with a classification problem, things like a confusion matrix is almost always going to come up. If you're doing a multi-class classification model, for instance, even a binary classifier anyway, a rock curve is a given when you're implementing a binary classifier. And then, I mean, when it comes to deployment, so the thing we did here is we just created an API, and this was because there was a bit of forward thinking, right, in what we were doing. With an API, the solution that was implemented can easily be integrated with an application like this that Unilas uses, right? Because this application is plugin, it's implemented using a plugin architecture. You can easily create a plugin that will make use of this web service that we're saying we created. Also, if the goal is to create, let's say, an independent or third-party web interface, it makes it a lot easier, which, by the way, is some of the things that we have been doing, experimenting with. So last year I was working with some student over the vacation. He did quite a bit of interesting work, right, where his solution is meant to be like this third-party tool that can be used by postgraduate students. So when you graduate, instead of submitting a CD, there's this independent application that you use, right? But the way that application works is it makes use of this API to automatically classify the ETD so that you don't have to go through a manual process. And then the third-party application synchronizes the content that you've entered into the application with this institutional repository. So someone from the library will log in and just verify these things that have been submitted are correct. And then boom, right? That's also possible because of the way that we deployed these models, right? Anyway, there's other ways in which you can do this. You know, you can just create some other standalone application that can be used by people from the library, right? Maybe a standalone application that will help them identify subject headings. You just point to the ETD, and then this application will automatically tell you to say the tags that you should associate to this ETD are these. So you just copy the tags and then just paste them as part of this workflow. showcasing how to update the keywords, right? Yeah, so there's like different ways in which you can, use these models. Almost always the case that you deploy them as like a web service, a standalone web service or something. Those of you that are interested in looking at this, I do encourage you to do that. We haven't really sort of like made significant changes in a while here, but if you go to, if you go to this repository, you should be able to get access to the source code. And I think there's some really scanty documentation that will tell you how you can test this out, right? So I mean, at your own time, when you have time, you might maybe want to go and play around with this. I do encourage you to do that. I don't know. So that you gain a sense of how the deployment was done. Actually, you can clone the repository if you wish as well. You won't have access to the source code. So what you have access to are the offline models. So the PICO file, PK file is what you find in here in the models directory, right? These are the PICO files. So, but I think I can share the source code also if you want the source code for the models themselves. So we deploy this and then we use the PICO file. So we used Flask to implement web service, right? So the way the web service is implemented is it pulls or it sends a request to the PICO file and then gets back the response or something. Yeah, and then just just showcasing the fact that you can actually so the models themselves, the web service itself, the Flask implemented service is on Heroku. I haven't checked this in a while. I'm not sure if Heroku hasn't taken it down, but I think it's still alive and well. I hope. But you can play around with this using your favorite tool. Maybe if you develop, I'm sure you'd use Postman or something. Oh my goodness, it's gone. That's sad. I'm not sure what happened here, but I have to revisit this anyway. Wow. Huh. Okay. This is interesting. I remember getting I have to fix this. I think I got a notification from Heroku. They're changing things here. Problem with managing so many different accounts, right? I'm sure that's the reason why. But either way, I'll try and see if I can fix this. But this snapshot is showcasing how you would. So I was using Postman here to showcase to say if you use a collection endpoint, for instance, and you feed it the title and the abstract, right? Using this JSON representation here, you see title, right? Which is the title, and then abstract and the corresponding abstract. You get back this response at the bottom here. It's showcasing the collection code and the collection name. So there you go. I'm not sure if people have any thoughts. I thought we could transition to the next use case. I don't know if people have thoughts or comments or questions or additions perhaps on.
Good evening, Doc.
Similar. Yes, hi.
Fine, thank you. Thank you so much for the lecture today as well. I've got just one question because you mentioned about the accuracy of the model. You said if we're getting a model that is probably 30%, what's the use? Now, that makes me think, what would be some of the obvious things that can cause a model to have less accuracy? Or maybe asking the same question the other way. What are the sources of errors for precision and accuracy in a model? Thank you, Doc.
Yeah, thanks a lot for one of question, and we discussed this at length very, very soon. But it turns out that there's a number of things here. So number one suspect, quality of data, right? That's one. Insufficient data. So if let's say, and I'll tell you this, right? If I come here, save. I don't know if you can see the coloration that exists here. Look at the accuracies for these different collections at UNZA, right? Education, medicine, natural sciences. And then I'm going to just briefly go to this breakdown here. I don't know if you can see, I mean, one would quality of data, insufficient data as well. So you will notice something like, trying to see if I can find VM here. Is that? You notice that there are set the collections that have a lot of data, right, will tend to be more accurate than those that have less data. I don't know if you can see that. Mining engineering, for instance, right? 0.47. But the 0.47 just multiplied by 100, it's like 47% or something. So it's a quality of data, insufficient observations, because when you are awake, so what we were doing here, right? If you look at, let's say mines, out of these 92, and I think what we were doing in the 92 is we were using a 70-30 split. Out of these 92, you're saying you're going to get part of them to be used for test training, right? So it'd be like 90, yeah, I guess, I mean, right? So you notice that, so the quality of the data and the number of observations. I mean, there are workarounds. You can augment this data. You can create synthetic data or something. You know, so yeah. So there are those factors to look at. It usually boils down to like quality of data, or something. But sometimes the nature of the problem, right? The nature of the problem. This example where we had this is like an unconventional example. What we were doing here is this, by the way, for those of you that might be interested in so wondering what was happening here. I'm just going to showcase what we're doing. Well, what we're doing in this particular example is we were trying to say for come on, I thought there was an example here. What? Oh no, it's should be here. So what? Yeah, should be it. I think. What we're the reason why that accuracy, what we're doing here is the way, and we discussed this the way this evaluation of the multi-label classifier was done, how this works actually. But what we're doing, right, is we are saying when you have a dissertation like the one Alinani's dissertation, right? When you have this dissertation, in this case, we say the multi-label subject classifier is supposed to tell you to say the tags, right, that this dissertation should be associated with should be these: 1, 2. Oh, sorry about that. I'm going to do this because this CCS concept encompasses everything. They're separated by these vertical dots, right? Interpunts. There's that. There's this. There's this. And listen, you get the point, right? As opposed to what you have, these manual subjects here. You see, people from library just said, well, the classification is agriculture informatics, agriculture data processing, agriculture innovations. This is wrong. It's like a computer science project, right? If you read the abstract here, PHP, Java, PostgreSQL, you know, develop, you understand what I mean? It's like software, classic software engineering type project anyway. There's a bit of AI also, I think, I don't know. But so the thing is, the evaluation is as a whole, right? You look at all of these subjects, right? Which is why it's a bit misleading to say, you know, 30% is very, very bad. It's not that bad for this type of work, right? Because you can see this. I mean, if you read this abstract, right? Forget about the food security thing here. But if you start looking at things like what the focus was, right? The main aim of this work was to automate, right? What else do we have here? The objective as follows: map the current business processes, right? What else? Develop. Develop. I mean, you can see here there's like cloud computing, develop a prototype system, and you can see here that, and I've forgotten what this work was about now, whether it had anything to do with AI, but you can see that some of these tags, right, make sense. Like it's about general computing, which makes sense. It's about human-computer interaction, classic here, because a piece of software was implemented. When you implement software, right, you have to use users to evaluate that piece of software, right? So human-computer interaction. If you look at some of these tags, by the way, it's because we used the archive as a basis for some of these things. So if you wanted to look up what C24 is, you can easily go to these are CCS concepts. You can easily go to, I've forgotten the type of CCS concepts we used here. I would have to check the actual version because it matters. CCS concepts that we use. Let me just check here. So in 1998, ACM CCS concept. So we can go here and just say 1998 CCS concepts, right? If you look them up, you can kind of like easily, and there's a reason why we use 1998. I know you're thinking, but why not use the more modern ones? I mean, if you can use the 1998 ones, you can use the more modern ones, but that's okay. So if you come here, right, you will notice that the way Alinani's dissertation was supposed to be tagged was C.2.4, C.2.4, right? Distributed systems, it's a bit off, right? I don't know, maybe because there was mention of like cloud computing, I don't know, I've forgotten what this was about. What else? D211, D211, software architectures, yes, right? What else? F11, right? F.1.1. Models of computation. I don't know about that, right? This has little to do with theory of computation, right? You can already notice why the accuracy is somewhat low here. H34 is like H.3.4. Systems and software, yes, right? H.3.5, same family. Online information services, yes, right? This is a web-based application. And then H.5.2. User interfaces, yes. So anyway, the sources of errors are varied. They depend on the problem. It could be the quality of the data, which is why, if you remember, right, I was mentioning here to say, before we got to a stage where we were augmenting title and abstract with mesh subject headings, we obviously looped back, right? Here, after evaluation, we notice that it's like 30%. Horrible. We go back to our business understanding and then identify alternative sources of data until we got to a stage where, surprise, surprise, we would get to a stage where we have, we move from, perhaps we'd move from, I don't know where that is, but would move from, I'm looking for where we have mesh. Yeah, there we go. So we'd move from this to this. Or rather, if you want to put it from 54, maybe 30 and 54 is a bad comparison, but the initial better accuracy was like 54. To move from 54 to 82. Right, so it could be quality of data, so many different things, but also the types of features that you're using for this model implementation. I don't know if there are any other questions or something. again, I'm hoping that our discussion of these case examples are giving us a very clear picture of these distinct phases associated with data mining. It's the same, right? You do the same things. Doesn't matter whether you're using SEM or something, you're doing the same things. But I've always thought, I think that looking at specific examples will help you gain an in-depth understanding. Some examples are very strange, right? Some examples will not use text. They'll use numbers. Some examples will use images as input. Some examples will use sound. But it doesn't matter whether you're dealing with sound, text, numbers, it's data, right? The only difference is, the major difference is how you're extracting that data, how you are pre-processing the data, how you get to transform that data, what sort of algorithms you're using, right? But the idea is the same. You go through these same steps. And that hopefully will make sense as we are going through the next example, right? So there's this project which is to do with identification of students that are at risk of failing. I've been personally interested in this particular project because there's a computer systems and architecture course that I've been teaching since I joined the UNZA. And the failure rate is very depressing, right? It's very depressing. And in their defense, I mean, everybody knows that computer architecture is probably one of those difficult concepts associated with computing. I know I had trouble understanding when I was a student myself. So but that aside, the motivation is simple here, right? Performance is a bit of an issue. If you want more motivation for this particular program associated with this course, funding, at least 90% of students would be funded by the government, right? So the motivation there is, if there's taxpayers' money that is being spent on these students, what can we do, right, to ensure that these people understand this subject area, or so that we prevent people from failing? Well, people that teach will tell you that one of the solutions is perhaps to pay closer attention to people that are more likely to fail, right? So that you introduce interventions to prevent them from failing. So the goal of the project is not to build a model that will help people pass. No. The goal here is to develop a model that will help you identify students that are more likely to fail. I don't know if there's a difference there, right? It's not a model to help people pass. It's a model to help you identify who will pass and who will fail, who is more likely to pass and who is more likely to fail. Now, you agree with me that if you identify who is more likely to fail, that's a good thing. Why is that a good thing? Then you can have a targeted approach, right? Where you have that group of people who are more likely to fail, and perhaps you spend more time tutoring them, right? The other weird things that you can do, for instance, you maybe identify areas where they're struggling, and then the targeted intervention would in part involve the tutor focusing more on those students during tutorials. Or perhaps have a separate dedicated tutorial group, right? Where more time is spent, right? Trying to make them understand or something. So there you go, right? The problem, the poor pass rate in the course. That's a problem. And so this graph at the bottom here is just showcasing, your typical grades that the students would be getting, right? So the number of assessments that we write, right? Quizzes, tests, and the final exam, obviously. A few practicals also. The quizzes are out of 10. Tests are always out of 50, and the exam obviously is like out of 100 or something. But the thing here is we are saying this model, right? You'd want to apply this model before they write the exam, obviously. And one would argue that maybe before they write the major assessments like test 3 and 4, something. So you'll notice from this graph that you have people that are getting 1 out of 10, 0 out of 10. If you look at Burundi, for instance, 0 out of 10, so we're trying to prevent that from happening. So how are we doing this? Well, so our solution was simple. We implement a predictive model, right? So a model that would tell us to say, out of these students, perhaps early on in the process, and I'm saying perhaps here because there are a number of features, right? When the students arrive, before they write any assessment, the model should be able to tell us to say, we suspect that that student are more likely to fail this course. And I know what you're thinking, but how, right? Well, maybe this will make sense what we look at the different features that we are looking at. It turns out, right, as part of business understanding, because I've taught this for a long time here, there are certain features like the minor program, the background of the student, right? Maybe the motivation as well. These are all factors that you can use early on in the process, whether a student is accommodated or not or something. What we've noticed is that, there are differences in people that have campus accommodation and those that don't. And if you are an educationalist, I'm sure you're already thinking, well, that makes sense. Maybe someone has to get on a bus, right? Come from home or something. There are students like that. You get on a bus, you come here, late at night, you jump on a bus, you're going back home, right? Or as your colleagues that have campus accommodation, you don't have to get on a bus, you just walk from campus. You can easily walk to the library or something. I'm holding out here, but I'm just giving you ideas of how you would apply this sort of predictive model early on in the process, right? So the intervention is simple. We're trying to identify students at risk of failing. So again, looking through the CRISP DM phases, this is a completely different domain, different problem, but the idea is the same. You're going through these 6 phases. Business understanding, what are the goals, right? Well, we want to be able to identify students that are at risk of failing so that we can hopefully devise corrective measures, right? And different types of corrective measures. In some instances, maybe you would advise the student early on to say the minor program that you've chosen is a bad idea based on maybe your performance in grade 12 or something. The other goal here is to continuously monitor these students, right, throughout the duration of the year, because this is a full course. So from February or March all the way up to November, they're doing this course, right? So we want to be able to use the model to monitor the students so that we apply corrective measures. By the time they're writing the exam, they're more likely to pass rather than fail. I mean, the obvious things that you'd be doing is, and I'm saying the obvious things that you would be doing is because I have intimate knowledge of this course. I've been teaching this for this is year number 5. I already know, right, how this problem can be addressed. I know factors that are strongly correlated with students failing. And some of them are supported by literature, right? If you study less, if you're not engaging with the course, you will fail. This we know, But anyways, so situation analysis to identify how this problem is currently being addressed. And you may be interested in knowing that one of the things that I personally would do is before this automation came into play, is students that would not be engaging with the course, right? You see them in class, they're not there, you look at the Moodle logs, you identify that there's some students that they only check Moodle once a month or something, or never check Moodle at all. You're not engaging with the course. And what we noticed over the years is that students that behave that way will perform poorly. You're not engaging with the course, essentially. The usual stuff as part of business understanding, when you're executing this project, you prepare a plan, right? By the way, there was a 4th-year project that was carved out of this this project. This has been a long-term project, but last year I worked with a group of, I did something anyway, but I worked with a group of students that worked on a capstone project related to this. So I'm going to point whoever is interested in this to perhaps look at what these guys did. the goal was to actually come up with very robust implementation. I'm still working with some students, a student this year, and we're trying to see if we can come up with an application that somebody like Lighton can use, right? An interactive application. This is work in progress, but you might be interested in reading that. You don't have to read the entire report. Maybe just go through the results of the methodology or something. You might find something interesting there, maybe not. But anyway, prepare a timeline. And then crucial to this project really, and this is different from previous projects, identify all the potential data sources. If you're saying you're going to implement a predictive model, the obvious question is, where is the data going to be extracted from, right? Well, in our case, quite a number of data sources or different types of data we're interested in. The assessment results for one, right? These things here. This would perhaps be used as input and as labels as well. That's one. Something else we would need is, because from past experience, we noticed that certain demographic factors are correlated with learning outcomes. We needed to figure out where we'd get the student demographics. You may be interested to know that this information is from SIS, right? A rich data set there. You know, your age, your gender, the school you were at, all those things, right? In our case, also, for some of the assessments that we conduct early on in the process, what we've noticed is students maybe that have done some sort of computer training, or those that have done computer studies, for instance, in grade 12, would perform better. Yeah. Right. And then what we discovered is, measuring engagement is hard, right? How do you know if a student is engaging or not? Well, the easiest way is to take attendance in class. That's what most people do, right? So those that attend classes often are engaging with the course. Now, in our case, over the past couple of years, because there are no marks allocated to attendance in most of the courses that I coordinate anyway, taking attendance was difficult, except for the last couple of 2 years, because the learning was somewhat online. So that process has been automated. But so using attendance as a way of measuring engagement was really hard. But what we discovered was that we could implicitly measure engagement by looking at the Moodle interaction logs. So we argue to say a student is more engaged with the course if they access Moodle more often than not. But also at some stage we had started talking to the tutors associated with the course to take attendance in tutorial sessions, right? So we have, for some cohorts, we have these details. For some, we don't, which makes it hard really in terms of the quality of the data. There's something really interesting about lecture attendance, right? I always give an example of an interesting project, computer vision project I know of, where I think it's Professor Gain it was, right? I'll try and see if I can find. So he proposed an approach where you could take attendance automatically by, I don't know if attendance. I don't know if there's attendance here, but maybe not. I wonder if there's a way of. I don't know if I can search for lecture. I've forgotten what that is, but yeah, using poll sheets and computer vision as an inexpensive alternative to clickers, right? Not really attendance, but I think what he was showcasing is how you could. So clickers are a nice way of getting feedback from students if you're asking questions in a class or something. So this was like a low-cost computer vision project where you use like a panorama or something to sort of like identify responses, but you can apply this to attendance as well. students always wonder why I take photos of them when they're writing exams. And for me, it's an easier way of maybe automating the process at some point in the future, right? Rather than manually doing some of these things. But so what I was trying to say is attendance in an in-class sort of setup could be done using this sort of approach. Right? It's an odd paper, but I think the ideas in here, when was this? It was like 2013. The ideas in here could pretty much be still applicable, like the idea itself, the technique, right? So some really, really interesting computer vision sort of like project. But anyway, so attendance and all those things. So these are the potential sources of data, right? But if you remember, as part of data understanding, what you do is you look at all the alternative sources, and then you evaluate the sources. Is the data going to be complete? Is it of high quality? And you're only able to do this by doing a preliminary data collection exercise, and then you do like the usual EDA process, exploratory data analysis. You are setting the quality of the data, right? So the usual stuff. Just to mention here that in terms of this particular project, just mentioned that there was some information that was missing, like lecture attendance, for instance, for certain years. What else is that? Tutorial attendance. In fact, for some years, like the last 2 years, tutors were not engaged, right? So tutorial attendance is scanty, which is why we actually don't use tutorial attendance as input to this model, right? Because what that means is if you have observations from certain cohorts that have missing tutorial attendance, either you just work with the cohorts which have a tutorial attendance, or you just get rid of that data attribute, right? If you remember our discussion. But you must remember that if you're getting rid of observations, your number of input observations is going to shrink. So for the case of this particular, to give you an idea, right? This particular project we're working with, in any given year, right? We start with 2017, 2018. These are the cohorts we've had so far, right? 2018, 2019. We started collecting data in 2017. 2019, 2020, 2020, 2021. And then I guess the current one, which is 2021, 20, is it 2021 or 2022? I think, I don't know. But so 5 cohorts so far. But you wouldn't want to use the current one as for implementing this model. This would be used as a test or something, right? Test data set. But anyways, so what we're saying is, if on average we have anywhere between 60 to 90 students in here. By the time we're around 90 here, I think this was almost close to like 85 or something. I think this was like in the 65s or something. Last year, I think we had almost like 50, 55 or something. But the point I was trying to drive at is a situation where if we're saying the last 2 cohorts, there was no tutorial attendance, then what you're saying is you're just going to work with these observations, right? You understand? So, and I just addressed a question to say what would typically cause a model, right, to perform poorly. Well, the number of observations that you're using. So we are better off using all the observations, but getting rid of attributes that have missing data. So you don't use them in the model implementation process, just get rid of them. You only get to use them maybe a couple of years down the line when you have so much data that you can get away with excluding, observations with missing data. I don't know if this is making sense. So anyway, insofar as like the sources of data is concerned, how the data was being extracted, the assessment results is probably one of the easiest things, because for me anyway, because I've been course instructor for this course since 2018. And so we meticulously have a record of all the assessments, all of these things I was showcasing here. These are manually computed. Every time there's a quiz, we take note of everything. We take this seriously anyway, like that. So 20 quizzes in a year, typically almost a quiz every week, except for cases where a topic is so lengthy that by the time you're writing a quiz, you'd have maybe covered, let's say, 3 weeks, maybe 4 weeks, like the current module that we just concluded, right? It took us about a month plus to conclude. But either way, this is manually compiled by the course instructor, right? So the input, the data source, CSV files. So there are CSV files with this data. And I have examples of how these CSV files look like. So this looks a bit iffy, but this is what you would see ideally. So student details, the computer number, the name, the score that they're getting, and the assessment itself. And because you're keeping track of the assessment, you can actually, somewhere down the line, we're planning to tie these assessments to topics, right? Because it's not like students who struggle in all the topics. If you notice the performance here, there are only certain areas where some areas the performance is really good, in some areas it's horrible, right? Maybe this would be a lot easier if I let's say go to, I think this is still available. I think I want to use this because it has anonymized data. The student details anonymized. I hope this link is still functional. But you'll notice something. There's a there's a pattern, right? So there are some topics. Observe. Look at quiz 6, for instance. By the way, those highlighted in red are the best performing, right? Maximum scores or something. You notice that in some topics, you have a lot of people performing better, right? Too many reds than whites. So topic 12, for instance, is probably an easier topic for the students to understand, right? As compared to maybe topic 4, right? I think that's like a von Neumann model architecture or something. Is it computer software? I don't know. But I don't know. I've forgotten. Maybe abstraction in computing. But what I'm trying to say here is that what could be done here, somewhere down the line, using this input data we're showcasing, we can do much, much more, right? We can tie the topic to the quiz number. Remember I mentioned that we decided to measure engagement using the interaction in Moodle. Well, how do you get the interaction logs? Moodle has a feature, right, that allows you to, I don't know how many of you have used Moodle, but anyway, if you go to Moodle, what you will notice is that there's an easier way of extracting these logs. I mean, if worst comes to the worst, you can go to the back end and extract data from the database. But there's a feature, right? There's a log feature that will allow you to view these usage logs. I'm not sure if this is making sense. This is strange. I don't know if it's everybody, but I have my mobile device connected and it appears the screen is not changing, right? And I wonder why. Is this the case for everyone? Which slide are you able to see right now?
Slide 69.
Okay, so maybe it's my phone then. That's okay. Thank you. Right. So I was hoping I could showcase the Moodle logs. I mean, so you can get them from the back end. And in fact, this slide here, this stuff was gotten direct from the database itself, right? But what you could do is for each particular course on Moodle, right? If you look at the first year course, for instance, there's a feature, right? If you go on more here, and you go to logs, you can actually filter what sort of logs you're interested in, the student or what actions you want. Let's say I want to get everything, right? I can see here that as recently as today, right, in the morning, a person accessed the Moodle log, the Moodle site, right? And by the way, the reason why these people are accessing the site is there's a test next week, I think. Is it after next week? What's the date? I forgot. Is it next? I think it's next week. There's a test, right? So what we're saying is we can get these logs, right? And getting these logs is not that hard, actually. And you can automate this, you can get backend, but you can also kind of download this, and I guess when you download this, that's when you gain an appreciation of the rich data that you're seeing here, right? So you can measure engagement in so many different ways. You can look at it holistically, and we spent a lot of time thinking about this, by the way, to say how would we measure whether somebody's engaging with a course by looking at the Moodle logs, right? Do we just look at how many times this person logs into Moodle? Should we look at how many times per week they are logging into Moodle? Should we be so nuanced that we look at, we exclude the vacation period? Should we look at specific things they are doing on Moodle? Some people are viewing the gradebook on Moodle, right? That's the only thing they're doing. Like this person went to the gradebook, right? Some people are going to download resources, right? This person downloaded a lecture. So there's so many different things, so again, we're simplifying this notion of engagement, but it can be looked at from so many different angles and perspectives, right? Ultimately, what we did in our case is we were looking, I've forgotten here, but I believe we got to a stage where we were looking at how do we measure engagement? I think there's something that we are doing currently. We're trying to write up this so I can easily look at the data set, actually, because I know the data set is there somewhere. Which is here. I just wanted to verify how we are measuring the excuse me, there we go. So again, these are anonymized ethics, right? So if you notice here, right, we using those Moodle logs, right? There is different attributes that we were able to pick out. So the hits, so we're looking at the unique hits in a year. If the academic year spans, I think what we ultimately set out for is academic year spans March 2021 until December. Like when I think we finished this course in November, anyway, that's when we concluded, November 2021. During this period, how many times did you access the Moodle, right? This is where the Moodle hits thing is coming from, right? And you notice that, look at this, right? 6 times. Now, there's something, again, that's very interesting, like this past 2 years, right? And I always tell this to students that performed poorly, say, you may have performed poorly perhaps because you're one of those people who had difficulties getting access to money for bundles, right? Life was expensive for most students these last 2 years anyway. So we're looking at this feature, 15 against 91 and all those things, 1 hit. It's quite sad. But anyway, so we came up with different metrics, and I think this weighting here was relative to this is from 0 to 1, but it was relative to the academic year. In an academic year, how many hits do you expect? And how many of those, right, is the student, what is the weighting relative to the student hits? So 0.17, 0.03, 0.17, 0.21, 0.38, right? So this would be used as an input feature. We tried to see if we could get fancy by looking at the different components of Moodle, right? So whether a student, the number of times the student was accessing files, right? That's another feature you can use. 58 times against 189 times, against 59, against 107, against 273. But you have to be very careful about some of these features, right? Because if I'm a student, right, I will download lecture 2 today or lecture 5 today. Maybe when I'm preparing for a quiz, if I'm preparing for a test that will include that topic, maybe I was using a device where I did not save that file. I'll go and download that file again. So you notice there that maybe using that as a feature may not be so wise. Maybe you'd have to figure out a way of uniquely identifying the unique files downloaded or something. I don't know, something like that. But the bottom line is, I'm just showcasing how engagement was measured and where the data was coming from. So usage log from Moodle. Some certain weird features, right? Like past experience and motivation. You can't get this from SIS, right? What we do is every year we have a preliminary survey that we have students fill out. So this survey will have just information that will enable us extract details to do with like what sort of past training these students have undergone, right? Their subjective motivating factors associated with why they're doing this course. Are you doing this because it was the only option? Are you doing this because you're interested in computing, for instance? It turns out what we've noticed is there's some correlation to some of this information we're collecting, But anyway, what you do then is, because there's this broad spectrum of information, right? That data sources, you have to select which attributes you're going to work with. And I think for some of these things I was mentioning during our discussion in the previous lecture. I don't know if this is making sense. But the other thing we're doing is, because we are pulling this information from different sources, right? Surveys, Moodle logs, assessment scores, SIS, we have to string this data together, right? We reconstruct it, we merge the data sets, right, from the different sources. And by the way, the merging of the data sets from the different sources is what ultimately gave us this kind of data set, right? This has information strung from all the different sources. Can't quite remember how many columns we have, 69 columns, right, from different sources. And then, of course, I want to make sure that at this stage you'd have already cleaned up the data, right? So there's something really interesting about the pre-processing associated with this data. Because some of the data sources are trusted sources, we didn't have to worry about pre-processing. Like information that we are pulling from Moodle is pretty much already standardized. Information coming in from SIS, that's it. It's an authentic, one would argue it's an authentic data source. The quality of data from there is reasonably good. It's okay. That's not the case for data from the survey, right? Uppercase, lowercase, camel case, errors in specifying the course code. Some will write instead of specifying the minor program, they are specifying the course, all those things. But again, all of these things I'm outlining, we will revisit them because it turns out that use case number 2 we heavily use when we start looking at pre-processing, data preparation, and model implementation as well. So we're going to revisit this use case and the previous use case as well also. All right. And then obviously, the easy part I've always thought is the model implementation. The same thing, right? You're evaluating alternatives. The paper the report from the students I've shared has those details. But also, I hope very, very soon we should be able to have, we should have been done with this paper by now, but I will share a draft version of this paper. I think by the time we're getting to the model implementation, this would have been finalized. So I will share this so that you have additional details, right, of the things that we did. So in terms of the model implementation, you notice that these are the things that we were evaluating. So there's something really interesting about the model we're implementing, right? Binary classifier, which is why we have this rock curve. Is this student at risk of failing? Yes or no, right? 1 or 0 something, which is why we have this rock curve, these rock curves here. And you notice here that the artificial neural network would probably be the best approach, or perhaps maybe followed by logistic regression or something. But So the numbers, or random forest rather, actually. No, it's logistic regression because 0.64. I wonder why this legend is not ordered by, oh, it's alphabetical, I guess. No, it's not even alphabetical, actually, because R comes, yeah, L comes before R. It's very strange. I don't know how the order was done, right? I don't know if you can see this, but very strange that, so I'm looking at these numbers, the area under the curve, right? Large is better, that's what we're saying. So artificial neural network, followed by logistic regression, and then naive Bayes, and then random forest, and then finally support vector classifier or something. But this is a work in progress. I'm sure we'll be able to sort of like optimize these things, right? I hope we'll be able to share this once we are done. But what we are saying here is the model implementation, right? You're just evaluating alternatives, feature combinations also. You know, what sort of result do we get when we just look at engagement alone in isolation, student demographics in isolation? What if we combine things? You know, what about the estimators, right? Naive Bayes, this is logistic regression, for instance, or random forest. Anyway, and then obviously evaluation in part would involve maybe testing this with somebody like Lighton, who actually uses this, and to ask, right? Or to construct an experiment that will find out if perhaps Lighton would find something like this useful, or any other lecturer, perhaps a tutor. Is this worth it? But most of all, how accurate is this thing? You know, is it going to show us the people that are really most likely to fail? Is it going to be relatively accurate? Maybe, maybe not. Is there a better alternative? I'll be the first one to tell you that we don't have a better alternative. With a large class, right, it's difficult. It can be overwhelming when you're dealing with a class of 60. Sure, when you write an assessment, you'll be able to see the people that will perform poorly. But if you're looking at doing this early on in the process, you need some automated approach like this, right? An at-risk prediction mode or something. And then, of course, in terms of the implementation, the students I was working with last year came up with some okay-ish implementation, but we're making changes. I'm working with a fourth-year student who is building some very nice interface, which is meant to use this